Today on How It's Made. Slate tiles. Hot dog carts. Garage door openers. And bicycle seats. History suggests slate may have first been mined in the Roman era, although the earliest confirmed records date back to the early 1700s. Slate tiles were used for general building construction and are still used today for practical and aesthetic purposes. These pieces of floor slate appear to be right from the quarry, but they're part of an 18-piece puzzle that's cut the same way every time. These pieces of wall slate are much thinner and are used for paneling. Uncut sheets of slate in a variety of thicknesses come straight from the quarry. After the slate sheets are stacked on a forklift, a worker carefully drives them to another part of the storage yard. He sets them down gently. Another worker splits the sheets of slate using a pneumatic zip gun. It's a delicate process. Once he splits the slate sheets, the worker inspects the lines in the pieces of slate and looks for cracks. Then he carries the sheet to a gauging machine. He checks the thickness of the sheet to make sure it won't cause jams on the cutting table. This multi-blade cutting table slices a sheet of slate into a series of strips. It's covered with recycled water. This lubricates the cutting process, cools the slate and cutting blades, and removes unwanted dust and particles. A conveyor slowly moves the slate sheet forward. A total of 18 diamond blades slice the sheet of slate into strips. These strips of slate will be used for wall paneling. This cutting table can cut several sheets of slate at the same time. Once the cutting process is complete, a worker inspects the strips of slate and sorts them according to thickness and width. Next, he piles some of them in preparation for splitting. He cracks thicker strips of slate using a stone splitter with a hardened steel blade. He makes sure they're thin enough to be used for wall paneling. Once the pieces of slate reach their final thickness, a worker places them in boxes, ready for installation. A worker inspects a sheet of slate that will be used for flooring. The thickness of slate flooring must be constant. He places a sheet on a conveyor. It takes the slate through a gauging machine where its surface will be made perfectly even. Using 2 diamond grinding wheels, the gauging machine shaves off any pieces of stone that exceed a preset thickness. After several minutes of shaving, the slate sheet emerges from the gauging machine. An employee checks the sheet to make sure it's smooth. First, he checks the underside of the eventual floor tiles. Then he checks the top side, the stone face that will be displayed. The worker places the smooth, flat piece of slate on a cutting frame. The computerized cutting machine cuts 18 pieces of slate according to a preset pattern. A high-velocity water jet cuts the stone at 3 times the speed of sound. The water is pure, filtered several times. The first time the slabs move through the machine, it cuts pieces 1 to 9. And the second time through, it cuts pieces 10 to 18. The worker snaps off excess trim and stacks the cut pieces of slate according to their numbers. All the number ones are identical to each other, as are each of the other numbers in the 18-piece pattern. Repeated on a floor, the 18-piece pattern appears natural. This non-porous slate comes in different textures and colors and can also be used in bathrooms or roofing. The first hot dog carts were rolled out in New York City in the mid-19th century. They were simple push carts with small charcoal stoves and served sausages on buns. Those sandwiches became known as hot dogs. A modern hot dog cart is a kitchen on wheels. Equipped with a water tank and sink, a steamer and grill, and a cooler, it's made to serve the public. And they're sometimes designed to stand out in a crowd. To make this hot dog cart, they start with molds for the hot dog-shaped body. A worker brushes a non-stick coating into the first mold. It will allow the completed part to be easily removed. He places fiberglass, one sheet at a time, in the mold. He brushes a generous amount of epoxy resin onto each piece. The fiberglass starts to solidify very quickly, but he leaves it to set overnight for a complete cure. They assemble the two halves of the hot dog-shaped body and apply bonding to the seams. A colorful paint job completes the look. Next, computerized tools cut holes in a sheet of food-grade steel. These holes will accommodate the sink, faucets, and other parts. Then the cooler door takes shape. Using a press, the worker bends up the edge of a piece of steel that's been cut to size. He transfers the part to another brake press. This one is computerized. It folds back the bend to give the door a strong, smooth edge. He repeats this process on two other sides. He then clamps a continuous hinge to the only unfolded edge, and he welds and rivets the hinge to it. Work now begins on the chassis of the hot dog cart. A worker welds heavy wall steel tubing to create a rugged framework. After painting it, he bolts the wheel axle to brackets on the sides. He tightens the bolts to an exact torque using a pneumatic wrench. He screws taillights to the bumper. The lights are surrounded by metal brackets to protect them from being damaged by customers waiting in line. The brackets also serve as a mounting plate. The team now transfers the fiberglass cart body to the chassis. They drill large holes to vent gas fumes and smaller screw holes to secure the body to the chassis. They line the cart with a molded fiberglass and styrofoam unit. It has compartments for the water tank and food cooler, and it also serves as an insulating layer. They install the steel food preparation surface, which has been equipped with a sink and faucets. A member of the team tightens a crimp ring around the hoses to supply water to the sink faucets. He runs a gas line to the steamer's burners and lowers the steamer into place on the cart. He assembles a barbecue to the other side of the cart, and this gives customers a grilled option for their hot dogs. They hinge the cooler door to the front of the cart. Once closed, the door seals the insulated chamber to keep hot dogs, sausages, and sodas on ice. The team presses bold graphics to the fiberglass shell and peels off the paper liner. And with that, this hot dog cart is ready to hit the street. Just in time for lunch. Decades ago, people had to get out of the car when arriving home in order to open the garage door. Today, it's routine to open and close your garage door at the push of a button, either on a wall-mounted pad or on a remote control. A garage door opener's motor drives either a belt, a chain, or a screw rod like these models. In turn, they move a carriage connected to the garage door. At this factory, the production line starts and ends at the same place. They take one completed garage door opener off the line, then start a new one by attaching a power cord to the unit's steel chassis. Then they place the chassis onto a traveling assembly fixture and plug in the power cord to prep the unit for testing later. They place the unit's plastic housing next to the chassis. Then snap in the plastic safety cover. This goes over the direct current motor, the equivalent of 1 1/4 horsepower. They attach an optical encoder to the motor. The encoder is a sensor which reads the door's position so that the motor knows when to stop moving the carriage. They place the motor against the safety cover, then screw it in place. In the housing, they install the motion sensor. It turns on the opener's light as soon as you walk into the garage or when the garage door opens. Next are the switches for programming the remote control and for setting the travel limits. These are the points to which the opener must move the door to fully open and close it. They then install the circuit board, routing the antenna for the remote control receiver to the outside. They plug in the motion sensor cable, then wire and plug in the connector for the light bulbs, and fasten the board in place with screws. They attach the electrical ground wire to the chassis, connect the power cable, and then the optical encoder to the circuit board. With all the internal components installed now, they affix the housing to the chassis. This completes the brain of the garage door opener called the operator unit. An automated testing machine now checks all the functions, simulating the load of the garage door. It also checks the light bulb sockets and the connection ports on the circuit board for the safety beams. The beams stop and reverse the closing door if they detect any object in its path. Once the operator unit passes inspection, it comes full circle to the end, which is also the start of the production line. A plastic lens to enclose the light bulbs, and the unit comes off the line. The carriage rail is milled from galvanized steel. It has slots for locking in plastic liners, which hold the screw rod. To produce the screw rod, the factory machines a solid bar of steel to the required dimensions and profile. Then, with high-pressure rollers, it forms threads in it. Workers insert the screw rod into the liners in the rail. For the retail market, rather than produce one long rail and screw rod, the factory makes 3 shorter connecting sections that fit into a smaller package. This machine lubricates the screw rod with grease. It helps it rotate smoothly in the rail liner when the opener's motor is running. When the screw rod turns, teeth on the base of the carriage interlock with the threads, moving the carriage along the rail. Workers first install the carriage base at the factory. Then they pack all the garage door opener components for shipping, starting with the rail sections and the operator unit. Last to go in are the wall-mounted control pad, the remote controls, and the safety beams, which you install on each side of the garage door opening. When you install the garage door opener, you insert the screw rod into the motor's drive shaft. Then you assemble the rest of the carriage, connecting it to an arm which attaches to the garage door. Motor runs, screw rod turns, carriage moves, and your garage door opens or closes. The bicycle is the most efficient mode of transport ever invented. 99% of the effort put into turning a pedal is transferred to movement. So the lighter the bike, the better. Using cutting-edge materials, a high-performance seat can weigh as little as 5 ounces. This company made a special seat for a past Tour de France winner. In fact, half the cyclists on the prestigious Pro Tour racing circuit use their seats. The design process begins with the simplest tools, pencils and paper. Designers sketch out a few basic ideas. Specialists then transform the sketched ideas into 3D digital images. The manufacturers machine model those images into a prototype. After testing, they begin the manufacturing process. A worker places a base or shell on the upper segment of a mold. This company makes their shells from a variety of carbon fiber materials. Polyurethane pours into the other section of the mold. This is the part of the mold that will give the seat its shape. When the mold closes, it cooks at a mere 104 degrees Fahrenheit. A chemical reaction takes place inside the mold, which causes the polyurethane to expand. 5 minutes later, an operator removes the seats from the molds. Here we see what the shells look like before and after. A worker removes excess polyurethane from the edges with a knife. While the polyurethane cures, workers prepare the cover material. The material is a proprietary microfiber specially made for this company. Not only does this material need to be flexible, waterproof, and comfortable, it has to be incredibly durable. Once they've cut the material into strips, the workers stack them on a stamping press. A die has been custom made to match the design of the seat. The stamping press descends with enough force to cut through multiple layers. It's now time to join the 3 panels of material that make up the seat cover. This facility has 2 different methods for attaching the pieces to each other. In this case, a skilled worker carefully stitches the material together. A different method of joining the panels involves a process called thermo-welding. An operator skives or thins the edges by shaving them so that there won't be a bump where they overlap. Double-sided tape will hold the material together. A special tape dispenser applies the tape to the skived edges. A worker positions the panels, carefully overlapping the edges. A vacuum system removes air from between the top and bottom sections of the press, holding the panels in position and ensuring there will be no bubbles at the seams. The press then heats the material up to 280 degrees Fahrenheit, ensuring that the adhesive bonds the panels together. The design of the shell for this seat has several slots in it to help create the right combination of flexibility and rigidity. A laser machine cuts stripes in the cover fabric to create a graphic element that reflects this design feature. Workers glue silver material under the stripes to highlight them, then brush glue all over the underside of the cover. Mounting the cover on the seat requires 2 operators. They place the covered glue side down on the seat, ensuring that it's positioned perfectly and that there are no air pockets. They work the cover into a small recess that runs around the perimeter of the base. They will then trim off the excess material with a utility knife. The amount of skilled manual craftsmanship required to build these seats is a key feature of their quality. but the company also relies on state-of-the-art technology. Bicycle seats sit on a framework called a rail. This facility makes rails from both carbon fiber and metal alloys, and it tests each one with the dynamometer. Workers put glue in the attachment points on the bottom of the seat to ensure that it passes a stringent safety test. A customized machine bends the seat to fit into the rail. The seat will then be bent back in the other direction to return it to its original shape. The seat is now finished. Fusing state-of-the-art technology with skilled craftsmanship, this company makes 520,000 bicycle seats every year. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.